The second half of the program is being kicked off by Haran, who's sort of introduced himself here already. Thank you.
Thanks, John. And yes, hi, my name is Anand. I'm a second-year fellow in this program. And therefore, this is my last EI symposium. And so before I begin, I'd like to just say a quick word of thanks to John and to Samantha and Natalie and everyone who has made this such a fantastic experience over the last 2 years. So thanks. My work is motivated by the idea of, or the concept of natural climate solutions, which has sort of refocused our attention on forests for the role that they play in absorbing CO2 from the atmosphere and mitigating climate change. And I'm particularly interested in tropical forests, which are at the same time the most biodiverse of all ecosystems, as well as forming one of the largest terrestrial carbon pools. With estimates suggesting that primary production, or the process by photosynthesis that absorbs CO2 from the atmosphere and converts it to biomass in tropical forests alone accounts for about 1,200 million tons of carbon every year. And the slowly accumulating stock of carbon in long-lived terrestrial vegetation in tropical forests has been estimated to be over 200,000 million tons. So that's a mind-bogglingly large amount of carbon. But these are a biome in transition. On one hand, even today, we are witnessing over 7 million hectares of species-rich native tropical forests being lost to deforestation, which equates to about 800 million tons of carbon being released every year, which is compensated to some degree by spontaneous regrowth of secondary forests in places that were deforested in the past but have been abandoned subsequently. But increasingly, there is a push toward afforestation or reforestation by way of tree plantations. And this is backed by policies aimed at mitigating climate change, aimed at reducing land degradation. And these have got further impetus in the last few years with the Paris Climate Summit and many countries making strong commitments towards reforestation. In fact, India has committed to increase its forest cover by 5 million hectares by the year 2030, with an estimated 2 to 3 billion tons of carbon being added to the terrestrial stock in the process. But the concern and problem here is that most of these reforestation programs in the present day do not give much priority to species biodiversity. And so if you take the case from India, data from just the last 3 years of afforestation records show that more than 120,000 hectares of new forests that have been planted employ a species pool of 5 or fewer species. And keep in mind that these are tropical habitats where native forests would have anywhere from 20 to over 100 species per hectare. So, and bear in mind, because this can be confusing to some, that what I'm referring to here are forests that are planted with a goal of long-term conservation and carbon sequestration. So these are not commercial plantations. So in essence, what we are seeing is a steady decline in the extent of species-rich native tropical forests, along with the concomitant increase in the extent of low-diversity plantation forests, such that the forests in the tropics of our future are likely to be composed to a greater degree by species-poor forests. And while we know fairly well that such a replacement of species-rich forests with species-poor forests is bad from a biodiversity conservation point of view, it's not that clear and has not been that well studied as to what are the implications for carbon sequestration and storage of replacing a forest composed of a high diversity of species with a forest composed of a low diversity of tree species. In theory, we expect to see a positive diversity productivity relationship. Basically, what the theory predicts is that forests composed of a great number of species would be able to utilize and take advantage of a finite set of resources than a forest composed of a single species, simply because when you have multiple species, you have multiple strategies targeting the same set of finite resources. But this biodiversity-based prediction can be countered by the fact that if you were to handpick your monocultures such that you were choosing the most highly productive species, then there is no reason to expect that your low diversity plantation would not be as productive or sequester as much carbon as your diverse ecosystem. So as such, from this theory, there isn't a single concrete prediction one can make as to what would be the implications of this transition, but rather what remains very interesting is to see what is actually happening on the ground in terms of the species that are being lost and the ones that are being planted. A second prediction of the theory is that biodiversity promotes stability. Again, if you were to imagine a forest composed of multiple species faced with a disturbance like a drought or a fire or an extreme wet year, chances are that that more species-rich pool comprises species that are able to tolerate these extremes of conditions, and therefore the diverse community experiences a greater degree of stability in, let's say, biomass production or carbon sequestration than a community with very few species. Now, both these predictions have been empirically tested to the extent of being done so in small-scale experiments, in microcosms, with grasslands and with herbs, but never really in terms of this real-world problem of forests, plantations, and carbon sequestration. So the goal of our study was to ask, given the transitions that we're seeing in terms of species-rich forests being lost and species-poor forests on the increase, would we expect to see that the forests of our future in the tropics would, A, store less carbon, would be less productive or absorb less carbon from the atmosphere on an annual basis, and in absorbing that carbon, be less stable or reliable through time. And the way one would ideally want to address such a question would be with an experiment where you set up monocultures in certain blocks and multi-species combinations in other blocks, or where you allow some blocks to spontaneously regenerate with native species. And obviously, we do not have the time or liberty to conduct that experiment. What we do have from the landscapes where I work in India is a very tidy natural experiment, where what has happened is, well, so in India for more than a century, forests have been managed and plantations have been raised for commercial purposes like timber and pulp and fiber and so on. But in the 1970s and 80s, conservation legislations that came in place put a complete ban on timber operations within India's nature reserves. So what you have today, at least within the nature reserves, is some areas which used to be, which had been harvested in the past, but were then spontaneously regenerated and have matured into mixed high-species tropical native forests, alongside similarly aged stands that were planted in the years before the 1980s, but were never harvested because of the implementation of laws. And so you now have a nice comparison between similarly aged and mature high-species-rich native forests and species-poor plantation forests. And so in one such nature reserve in India called Anamalai in the Western Ghats biodiversity hotspot, we addressed our first question looking at standing carbon stocks. And we looked at 4 different habitats, teak plantations and eucalyptus plantations, which are significant because teak and eucalyptus are the 2 species that even today are among the most popular in large-scale afforestation programs in India. And we compared them to evergreen forests and deciduous forests. And these are significant because teak and eucalyptus, where they are grown, overlap in terms of broad bioclimatic space with both deciduous forest types as well as evergreen forest types. So we established plots in each of these habitats and estimated standing carbon stocks using published allometric equations. I can discuss this in detail with anyone who's interested after the talk. And so coming to the results, the first one is merely a description of what you would expect. This is tree species richness per plot, and as expected, the forests in green have more species per plot than forests in blue, but that's not surprising. That's what we expected to begin with. For carbon stocks, the evergreen forests stand out with an average stock of about 200 plus tons carbon per hectare, while the deciduous forests were no different from the eucalyptus forests, with both being slightly lower than the teak plantations. And so in response to the first question about carbon stocks, what these results show is that given enough time, even low diversity plantation forests can match the standing carbon stock of higher diversity native ecosystems, at least in some instances, if not in all. The second thing we were interested in was primary production, or the uptake of CO2 from the atmosphere on an annual basis. And to do this, we relied on remote sensing and something called the Enhanced Vegetation Index, which is derived from the Landsat series of satellites, and basically draws information from the red, the near infrared, and the blue bands. And other studies have shown that the EVI is strongly and positively correlated with gross primary production, which, as I've defined previously, is the amount of carbon fixed by photosynthesis at any given point in time. What we did then was to pick, along with Anamalai, which was the first site, 4 other sites, again in the Western Ghats, and these were picked specifically because they have substantial areas under teak and or eucalyptus plantations. And what we then did was to look at EVI, trends in EVI within these habitats. So in essence, this is just an example data from one of the forest types in one of the sites across a time series from the year 2000 to 2018, which was a period interspersed with some years of excessive rainfall, well over the long-term average, as well as some years of drought. And what we were interested were in 2 properties of this response. One was the average, so the average across this time period with higher values corresponding to a greater amount of biomass production, as well as the stability, which is the ability to resist large fluctuations from year to year. And this was indexed as 1 over CV, 1 over the coefficient of variation across this time span. And we compared within each of our sites the different forests and plantation types. So summarizing those results, first we look at the average EVI. There's a lot going on here, but I'll draw your attention to 2 things. One is that the greens, the evergreen and deciduous forests, are consistently always higher in terms of average production than the dark blues, the teak plantations, but not consistently different from the light blues, which are the eucalyptus plantations. So just like we saw with the previous set of results, certain types of plantations, in this case eucalyptus, can appear to be as productive on average as the native high species diversity forest ecosystems. But in contrast, when we look at stability, there's a much clearer signal. The stability of the greens, which are again forests here, are without exception always a bit higher than the stability through time of the blues, which are the plantations. So the next thing we're trying to explore, and I use the word explore because that's literally what we're doing at this stage, we haven't run any formal statistics on this yet, is to test the prediction that if you look at this graph, which shows rainfall from normal in the center to wet and dry, the prediction of biodiversity ecosystem function theory would be that the difference between forests and plantations would be at its least when conditions are normal, but would inflate when situations deviated from that normal in terms of during very wet or very dry years. And like I said, we haven't run the statistics yet, but just plotting the scatter out and running a few smoothing curves through this gives an idea that there might be something along those expectations that are worth pursuing. So here we see evergreen forests on top in green and the teak plantations in blue. And as this would predict, the smallest differences are very close to when precipitation is closest to normal, while expanding to larger differences as you go towards the wetter on the right and drier extremes on the left. So this is something that I'm currently working on and trying to formalize in terms of the analysis. So to summarize the story, in terms of carbon stocks and average production of biomass, or the quantitative side of carbon sequestration, what our results suggest is that there isn't always much to pick between species-rich forests and species-poor plantations. Under certain conditions and certain types of plantations can in fact match the carbon storing and biomass producing potential of species-rich forests during average, when conditions are normal. But where things are different are when we look at stability, where the forests seem to be far more stable and therefore far more reliable in terms of their ability to sequester carbon than are the plantations. And so if we value this qualitative superiority of carbon sequestration by forests, which is something that we might well do because most predictions suggest that the climate of our future is going to comprise of more droughts and more extreme wet periods, then maybe there is perhaps the need for us to emphasize a bit more the role of tree biodiversity in climate change policy, because of the stability benefits. And doing so might mean giving more priority to spontaneous regeneration of native forests versus establishing of plantation forests, or when we establish plantation forests, to bring in a greater degree of tree biodiversity and native species into those plantations. And doing so would not only have the benefit of a greater quality of carbon sequestration, but also potentially have various other co-benefits when it comes to biodiversity and other ecosystem functions and services. So I end with that, and also thanking my funding sources, collaborators, and everyone who has helped me to implement this project. So thank you.
So we have a little bit ahead, so we've got plenty of time for questions and things.
From one of your very interesting talk, and from one of your final figures, there didn't seem to be any evidence that these trees suffered drought stress. In fact, almost the opposite. Mm-hmm. Can you explain that?
So I don't think I can explain that today and based on this data set. All I can speculate on is that there are likely to be some sort of lagged effects, because a drought operating in a given year probably impacts the forest many years, for a bunch of years beyond the actual drought event. And I do not have the temporal bandwidth to test for that. So that's one possible reason that the forest is experiencing the impacts not just of that year's drought, but accumulated over the past 5 years to 10 years. So that's a thought. And I'm open to other suggestions for what might be going on. But I do know that there's a paper from the Amazon that in fact shows this very thing of forest during drought years in fact having higher EVI scores, potentially being more productive.
Yeah, good talk. Do you know, is there any data on, or could you speculate on how these two forest types respond to pests or disease differently?
This is speculation again, but it's possible that the evergreen forest is more resistant. The composition of the leaves with their tannins and so on is probably of a higher degree in the evergreen than in the deciduous. So leaves are possibly on average less palatable, but in terms of pest outbreaks and the frequency of pest outbreaks and so on, I do not have an answer.
So you mentioned things like a teak plantation that could have an equal productivity to a more diverse forest. What is the unique property of the high productivity teak forest versus the low productivity teak forest in that high amount of spread that you see at the low diversity end of the spectrum?
Can you guide me to which result?
The answer is no, because I can't remember which figure, but one of the things you said is that there were places where there were high diversity forests and low diversity forests that had equivalent productivity. There was a curve, and then you showed other things in your data that also showed the same thing, right? Where some of the teak forests had productivities that were pretty high, right? Like, for example, here.
Okay.
There's a very large spread in teak values if you just look at these.
Right.
What makes it? What turns one into a high value versus a low value? Is it climate, or is it a management practice, or what are the things that contribute to that spread?
It's hard for me to say, but at least in terms of, you mentioned climate. When a part of the study design was to attempt to control for other things that might differ between these habitats. So literally they sit next to one another in the study. So while the differences across sites might be due to climate, within any one site it's something more local that I have not measured. I have made sure that through, again, satellite-based assessments, that there is no asymmetric impact of fire, for example. But I do not have the resolution to explain why there is a large variation in teak. They are all fairly similarly aged. It could be localized mortality in some places, but not in the other. But it's not something I've measured.
Related to that, I think it's a few slides back, you had the diversity of the teak forest and eucalyptus forest compared to the others.
Yeah.
What's the does it mean that the teak somehow exclude other things from growing in there?
So it has been argued and shown that the leaf litter of teak is quite a toxic growing environment. Which explains to a degree why when you leave a teak forest alone, you don't always see a spontaneous regrowth in the understory. And same is true for eucalyptus, but at least in this study, the eucalyptus seems marginally better than the teak. But there are other studies that have recently been coming out which show that, and the mechanism is still not known, but you will observe very young cohorts of trees, but for some reason they do not mature into the size classes that one might classify as adults or that might be relevant for carbon sequestration. So there's certainly something going on there that I'm interested in pursuing in the longer term. But there is something about both these species that inhibit spontaneous natural regeneration.
If I may ask a follow-up question, if you have teak growing naturally if you have teak growing naturally in a forest, are the trees more not interested? I mean, is the spacing between trees bigger such that they don't have that same kind of an effect?
The spacing between teak trees themselves?
Right. I mean,
yes.
with other trees in between.
Yes, because in fact, although it's a bit contentious, these are all habitats that originally had teak in its wild form. But back when that was the case, they were at a very low density. And today, the densities of teak that you see, even outside of the so-called plantations, is in some way biased by the fact that plantations exist close by, and there might have been, or that those places were managed in the past for plantations and some trees were left behind. But there is no other evidence to suggest that teak is highly clumped in its distribution in its native form.
Do we have time for one more? Oh, very nice presentation. So the one thing that I was curious about was that I was surprised that the EVI would have dropped on the right side for the excess rainfall. I would have thought it would be more like an upper asymptote or something that you approach. So maybe if you could explain that. The other thing is just, I think you kind of already touched on it, but it seemed odd that they would be replanting in either monoculture if it's not for essentially some commercial value. And maybe it's just because they did at one time expect to harvest and now they've just protected them, but I'd be curious to know why they did that.
Okay, both are great questions. I'll address so again, my study does not tell why that is so, but I have, again, two speculative points. One is that wetter years potentially had less sunlight, and therefore growth was didn't reach the potential that the water might have enabled. Two is inundation of soil, which is again known to inhibit primary production. And in fact, the sort of global relationship between rainfall and productivity does asymptote and fall away. And the reason why it falls away beyond a certain rainfall limit is, in fact, inundation and the lack of sunlight. So that's the theoretical speculation, but I don't have. As for your second question, it's interesting. So if you look at the policies today, it's very clearly stated in the policy that diversity is important, we should use native tree species, and all the words are there. But on the ground, the infrastructure cannot yet support multi-species plantations. The nurseries, nursery staff, and all the training, the supply chain is geared towards teak, eucalyptus, and a few other species. So I would imagine that the recognition is there, the intent might be there, but on the ground, we're still seeing extensive areas brought under very low diversity. So it's thanks.
Is it quick? This is the last one.
Related question to that, really quick. How many images are you basing the EVI on?
Okay.
These are pretty cloudy places,
Yes,
and
yes,
you need real light and real views to actually see them. And I can imagine, having tried to do this in
Yes.
other wet areas, I can
Yes,
imagine you don't
yes.
have very many.
You're absolutely right. And so every year has somewhere close to 30 images being captured. And so for every year, I am using an annual median. The annual median across all tiles for that year. And so there are obviously some times of the year when data are just not available for any year. So in the Western Ghats, from July to mid-September, you cannot hope to find an image at all. So in fact, we're missing data from the rainiest part of the year. So what we're looking at is the annual median composed largely of images from January to May, and then from October to December. And while there might be some biases associated with that, at least it's a consistent bias right across the study and right across all the habitats. So thanks.
Thanks.